everyone. What we're going to be working on today is how to solve rational equations. A rational equation is basically an equation that has one or more rational expressions. So obviously this is an example right here. So the steps to solving a rational equation are listed out right here. First thing we're going to do is factor, factor, factor. Any numerator or denominator that hasn't been factored for you needs to be factored. We're then going to look at those denominators that have all been factored and calculate what the least common denominator will be. The reason we do that is we take the least common denominator and we multiply all terms on both sides of the equal sign so that we can eliminate the denominators. Once the denominators are eliminated, we'll have a pretty straightforward equation to solve. When we get our answer or answers, what we have to do is we'll have to check and make sure that we don't have any conflicts with our denominator. We all know that we cannot have a denominator that equals 0. So we're going to have to identify the values that would make our denominator 0 and make sure that our answers don't conflict with that. If they do, we cross it out and we say extraneous solution. So let's go ahead and let's solve the first problem. By the way, you might have noticed this over here. I don't know why that's there, but we're just going to pretend it's not. Okay, so the first thing we're going to do is we're going to factor this denominator because these two are already all set. So when we factor this, you should easily get x plus 4 times x minus 1. And if you notice, what we have here is x plus 4 and x minus 1. So the least common denominator will be x plus 4 times x minus 1. Now, this might be a good time to kind of decide what our restrictions on the denominator are. So why don't we do that? Basically, we know that x plus 4 cannot equal 0. And we also know that x minus 1 cannot equal 0. If they do, then we're going to have denominators that are 0, and they're undefined, so we wouldn't be able to, the equation wouldn't make sense. So x cannot be negative 4, and x cannot be 1. So those are the restrictions on our denominator. We'll just kind of put that aside for a second. And now let's go back to our equation and let's multiply every single term by x plus 4 times x minus 1. So when we multiply this, x plus 4 times x minus 1, we're going to multiply the second equation by second expression, x plus 4 times x minus 1, and the last one, x plus 4 times x minus 1. Now, I'm going to be honest, you might find some efficiencies as you do this, and I'm okay with that as long as you're getting them right. So what you might notice here is that x plus 4 over x plus 4, they cancel each other out. So we're left with x times x minus 1. I'm going to go ahead and distribute that right now. We'll get x squared minus x. And again, that was because we had x times x minus 1. For the next term, what I would suggest you do is make this plus a negative. Okay, so we don't lose our negative sign there. Now we have negative 2 times x plus 4 times x minus 1 over x minus 1. The x minus 1's cancel each other out. So now we can distribute negative 2 into the parentheses. So we'll have minus 2x, and then minus 2 times 4 is 8. Equals, and our third fraction, everything will cancel out. So we're just left with 20. Now remember, I told you all the denominators should cancel out, and they did. So now we just have a quadratic that we have to solve. So let's go ahead and let's consolidate our terms. And we know that anytime we have a quadratic equation that we're going to solve, we need to set it equal to 0. So we'll move the 28 over, leaving us with x squared minus 3x minus 28 equals 0. And we'll use the zero product property at this point once we factor it. Okay, so let's go ahead and factor it. Two numbers that multiply to equal 28, negative 28, sorry, that add up to negative 3. So of course, x and x, you might be thinking 1 and 28, 2 and 14, 3 doesn't go in, 4 and 7, that's the one. So we're going to have x plus 4, x minus 7. And when we solve these, we get x equals negative 4, or x can also equal 7. Now, we've got our two x values. But look over here. This is where we check. Do we have a conflict? We absolutely do. X cannot be negative 4. Think about it. If we put negative 4 into this equation, we would have 0 in our denominator, wouldn't we? And so that would be an undefined fraction. So the only solution we have to this equation is x equals 7. Let's go ahead and let's do the next one. Okay, so the next one, what I want you to do is I want you to factor out every numerator and every denominator that you can. Remember, sometimes things can't be factored. So obviously there's nothing to do here. X squared minus 5, it almost wants to be a difference of two squares, but it's not because 5 is not a square. But this one, we get x minus 1 times x plus 1. This numerator, two numbers that multiply to equal 2 that add to equal 1. Nope, can't come up with that. So we're just left with this fraction right here. So hopefully you can see x minus 1 times x plus 1 will be our least common denominator. That contains all of the elements of all of the denominators. This one is just over 1. So least common denominator, x minus 1 times x plus 1. Let's go ahead and let's write our restrictions. So x minus 1 can't be 0 and x plus 1 can't be 0, which means x cannot be 1 or negative 1. So we're just going to keep that aside now, and we're going to go ahead and now go back to the equation and solve. So remember, what we do is we're going to multiply every single term by x minus 1 times x plus 1, which, by the way, is the same thing as x squared minus 1. So I'm going to do a rewrite here just to make sure that everybody understands what we're doing. So we take our first term and we multiply it by x minus 1 times x plus 1. Then we take our second term, which is x squared minus 5, and we x squared minus 5 over x squared minus 1. And we're going to multiply it by x minus 1 times x plus 1. And then we're going to set it equal to x squared plus x plus 2 over x plus 1. And now we're going to multiply all of that by x minus 1 times x plus 1. I'm running out of space here. Okay. So let's go ahead and see what happens here. Well, nothing cancels out here because there was no denominator. So I do want to remind you that this actually was x squared minus 1 before we broke it apart. So we will go ahead and simply distribute the x into each term. We wind up with x cubed minus x. In the second fraction, we had a denominator of x squared minus 1, and we multiplied it by x minus 1, x plus 1. Well, remember, that is x squared minus 1, just broken apart. So this entire denominator gets canceled out. Okay, both of these terms get canceled out with x squared minus 1. So we just add the numerator, x squared minus 5. And on the fraction on the right, x plus 1 and x plus 1 cancel out, which means we have to distribute the x into the parentheses and then distribute the negative 1 into the parentheses. So x times x squared is x cubed. X times x is x squared. X times 2 is 2x. And then negative 1 times everything in the blue here will just change their sign. So minus x squared minus x minus 2. Take a moment to go ahead and consolidate the left side and the right side of this equation. Pause your video for a second, do it, and then come back and let's make sure we have the same thing. Okay, so let's see how you did. You may have had the x cubed and the x cubed on each side. I just happened to notice that they would cancel out, so I got rid of them right now. So again, we're down to a quadratic equation, so we're going to solve this. We're going to move over our x, and we're going to move over our 2. So we'll subtract x and add 2, which gives us x squared minus 2x minus 3 equals 0. And we're going to go ahead and factor that. So we need two numbers that multiply to equal negative 3, that add to equal negative 2. I hope you got this one quickly. It should be negative 3 and positive 1. And when we go ahead and solve those, we're going to get 3 and negative 1 for our solutions. Now remember, we have to make a little check over here. Do either of those solutions conflict with the restraints on the denominator? It does, doesn't it? We cannot have x equal to negative 1. If we did, this denominator right here would be 0, making that an undefined fraction. So the only solution we have, x equals 3. Okay, so please go back and look at this again if you're having some trouble, but hopefully these two examples will allow you to do a couple of problems for homework. I'll put that in Google Classroom. Have a great day, everybody.